So one of the first things that we need to do is to be able to add, subtract, multiply, and divide functions. Let's say we are given f of x and g of x, where f of x is x squared plus 2x plus 1, and g of x is x plus 1. First, let's add f of x and g of x. Notice that the parentheses f plus g, then parentheses x, is the same thing as f of x plus g of x. In order to add these functions, we need to add like terms. Therefore, for this example, we're going to write f of x plus g of x by substituting what we know for f of x, which is x squared plus 2x plus 1, and notice that I placed f of x in parentheses to show my substitution, plus g of x, which is x plus 1, also in parentheses. Since we are adding, we can rewrite the equation without parentheses, and then adding like terms, we get x squared plus 3x plus 2. Now let's subtract g of x from f of x. Notice the notation parentheses f minus g in parentheses of x means f of x minus g of x. Substituting our functions, we get in parentheses x squared plus 2x plus 1 minus in parentheses x plus 1. I like to distribute the minus sign as a negative into the second set of parentheses so that I can add like terms. This will give me x squared plus 2x plus 1 minus x minus 1. Adding like terms, we get x squared plus x. For multiplying and dividing functions, notice the notation. We have in parentheses f times g, and then another set of parentheses for the x. Just remember that this means f of x times g of x. Substituting for our functions in parentheses, we have in parentheses x squared plus 2x plus 1 times in another parentheses x plus 1. You should be able to multiply these polynomials, but I will show you how I like to multiply polynomials. First, I like to write the multiplication problem vertically. So on top, I will have x squared plus 2x plus 1 times x plus 1. This should resemble a 3-digit number times a 2-digit number. For example, if I had 123 times 45. Here we would multiply every digit on the top number by 5, then multiply every digit on the top number by 4, and then add. Similarly, I will multiply every term in the top polynomial by 1 and get x squared plus 2x plus 1, and then now multiply every term in the top polynomial by x and get x cubed plus 2x squared plus x. Notice where I write these terms. I line them up according to like terms so that it makes adding easier. And when I add, I get x cubed plus 3x squared plus 3x plus 1. When dividing functions, notice the notation and rewrite it as f of x divided by g of x. And note that g of x cannot equal to 0. Should g of x equal to 0, the division would not be possible. For our purposes, we will divide functions by factoring the numerator, factoring the denominator, and then simplifying our fraction. Our division problem then is x squared plus 2x plus 1 divided by x plus 1. Factoring the numerator, I have x plus 1 times x plus 1, and the denominator is just an x plus 1. We see that the factor of x plus 1 is in both the numerator and the denominator, so we can simplify our fraction, and the result for our division problem is x plus 1, as long as x does not equal to negative 1. If the fraction does not simplify, we have another method to try, but that will be discussed later in the course.